must understand few things. Any flow which requires to be heated or cooled but does not change in composition is defined as a stream. So what is stream first? Any flow which required to be heated or to be cooled but does not change in composition is defined as a stream. Okay, this is the one thing. So if somebody says that what is stream, you must know about that. You have to heat or cooled, but whose composition does not change anyhow condition. Okay. Second point is, what is cold stream is there. So cold stream is nothing but which starts cold and needs to be heated up. Needs to be heated up is known as a cold stream. Okay. Then what is hot stream? Hot product that is starts with the hot and which must to be cooled down, which must to be cooled down, that is called as a hot stream. So conversely, the reaction process is not a stream. If we say that there is a exothermic reaction in reactor, can I say it's stream? No, there is a reaction is happening in the reactor. So this is the part of the stream only in the pipeline kind of thing. Okay, this is not the part of inside the reactor. There is a different phenomena for the reactor. How to integrate the optimization in reactor by use of addition of inert species. That is, you use the steam or coolant or jacketed phenomena. That is the control of reaction, control of temperature is there. That is the part of exothermic and endothermic that must not be included in this heat exchange phenomena. Okay, because it involves change in chemical composition in the exothermic or endothermic reaction, and makeup flow is not a stream. Please listen carefully, this important point. The makeup flow is not a stream. Okay, if you add something or you can make up stoichiometry of the reactions, so that is not the part of the stream. Stream only indicates that to be heated or cooled but does not change in the composition is called as a stream. Okay, then starts cold and needs to be heated is called as a cold stream. Hot product or starts with the hot which is called as a hot stream. Okay. Then next is the reaction process is not a stream. Okay, makeup flow is not a stream and it is not heated or cooled. Now come to the point, key steps of pinch technology. There are 4 points. It includes, first is the data extraction. So we already know the data extraction. It's a simple phenomena. I will tell you how to extract the values, how to define the flow sheet, how to define or calculate or estimate the data extraction point. You have to estimate or you have to measure the temperatures. You have to compute it, separate out the temperatures. You will get, that is the part of data extraction, which involves collecting the data for the process hot and cold utility system. Second is the targeting, which establish target for design in terms of energy, number of units, area for best performance. That is a part of pinch analysis. How much energy you can save, how much number of units required. Less number of units, satisfactory. Area, that is heat transfer area. How much heat transfer area you can minimize for your performance for your particular system to get the best performance. Next is the design, where an initial heat exchanger network is established. That is the last part where you have to uh, set the heat exchanger. Where you have to set the heat exchanger. Like here, I want to add one heat exchanger. Here, I want to add one condenser at this place. That is the location point of view where you must have to put your heat exchanger. Okay. Last is the optimization. Optimization phenomena is based on your delta T minimum temperature difference. That is the part of costing. So less delta T minimum, less utility required. Okay, so it's based on your cost as well, how much heat exchanger required, either higher or lower. That we will consider in the concept of minimum temperature approach. I will tell you. So start with the data extraction. So here is the flow sheet. Have a look at the flow sheet. So here the inlet temperature is 50 degrees Celsius. Inlet feed temperature. Have a look. Okay. Then it comes to the heat exchanger. One heat exchanger is over there. Why we add heat exchanger here? Because my reaction temperature is around 200 or 220 degrees Celsius. So I want to reach at that temperature. I use here one heat exchanger. 50 degrees Celsius to 210 degrees Celsius I want to reach. So there will be one heat exchanger over there. Okay. So there is a requirement of steam. So I can use here steam to heat that feed to reach the temperature 210. I use here steam. Okay. Again, at the outlet of reactor is 270 degree. Outlet of reactor. Have a look. The temperature is 270 degree. Right. So I want to cool down. I use another heat exchanger. That is nothing but the condenser kind of thing. I use here cooled water as a medium. Okay. So I want to reach around 160 degrees Celsius. Now I want to separate the products, byproducts, or mixture by use of one unit operation is there. Suppose it's a distillation column is there. So I want to separate it. So again I will operate it 160 or 200 degrees Celsius. Again there is a use of energy in reboiler. 220 degrees Celsius is the outlet composition of unit operation, and want to reach around 60 degrees Celsius. Again there is a one condenser over there after the reboiler, because 220 degrees Celsius is the reboiler outlet composition. Now I want to reach around 60 degrees Celsius. So there is one condenser over there, and at the top, have a look. 130 degrees Celsius is there. So again, this is the unreacted feed is there. This is the unreacted feed. So I want to pass again to the reactor. So here they use compressor. One compressor thing is there. So there is in terms of gases is there. Okay. So they compress these gases and pass to the liquid. So 160 degrees Celsius again pass to the reactor by use of one heat exchanger. Why they use one heat exchanger over here? Because my temperature, compressor outlet temperature is 160 degrees Celsius. Now my reactor temperature again 200 to 220 degrees Celsius. So I want to reach over there by use of one heat exchanger, that is use of again steam. So there are two steams, then cooled water is there, then there is a reboiler condition, there is a 220 to 60 degrees Celsius, there is again one condenser over there. So how we data extract it? So you must note down the hot stream and cold stream first. You must note down the hot stream and cold stream first. So first is here there is a one cold stream.